Hey coders, welcome to Code with Me. Today we're starting something really exciting, React. And don't worry, I'll explain everything like you're in 6th grade. Super simple and fun. So, what is React? Imagine you're building with Lego. Each tiny block helps create something big, a house, a car, anything. React works the same way. You build websites by putting together small building blocks called components. React was made by Facebook, and it's used by websites you probably visit every day, like Instagram, Netflix, and even Facebook itself. So if you've used any of those, you've already seen React in action. Now, let's talk about something cool, SPA versus MPA. Think of an SPA, or single-page application, like your house. When you move from the kitchen to the bedroom, you're still inside the house, right? That's how SPAs work. You move around inside the website, but the page doesn't reload every time. It's fast and smooth. On the other hand, an MPA, or multi-page application, is like a shopping mall. Every time you go into a new store, you exit one and enter another. That means every time you click a link, the whole page reloads. React helps us build SPAs, which feel faster and smarter.
Quantum entanglement from reverse Higgs boson particles disrupts the geospatial algorithm, preventing us from locating.
Now, let's get our React playground ready. You only need 3 things. 1, a browser, like Chrome. 2, a code editor. I recommend Visual Studio Code. 3, and Node.js, a little helper tool that lets us run React projects. Once those are installed, we can use tools to kickstart a new React app. Here are a few options. Create React app. This is the classic starter kit. Vite, super fast and modern. Parcel, also cool, but we won't focus on it today. Most beginners use Create React app. It gives you everything you need right out of the box. Now, here's where the magic starts. JSX. JSX is like a superpower. It lets us write code that looks like HTML, but it's actually JavaScript. Let me show you. JSX function hello, return h1 hello world. See that? It looks like HTML, but it's part of a JavaScript function. That's JSX. Before JSX, we had to write code like this, jsreact.createElement h1 null hello world. Yeah, that's a bit too much. With JSX, we can simply write JSX h1 hello world h1. Clean, easy, way better. And that's it. You just finished your first step into the world of React. Now you know what React is, the difference between SPA and MPA, how to set up your tools, and a sneak peek at JSX. We're going to set up React on your computer so you can actually start building awesome apps. Don't worry, I'll walk you through every step, even if you've never done this before. So let's go. Install Node.js. React needs something called Node.js to run behind the scenes. It's like the engine that powers your React app. So open your browser and go to nodejs.org. You'll see 2 green buttons. One says LTS and one says current. Click the LTS one. That means long-term support. It's more stable. Download it, install it, and you're done. To check if it's working, open your terminal or command prompt and type bash node-v. You should see a version number like v20.11.0. If you see that, you're good to go. Step 2, create a React app. There are many ways to create a React project, but we'll start with the easiest. Create React app. In your terminal, go to the folder where you want your project to live. Then run this command. npx create React app, my React app. Let's break that down. npx runs a tool without installing it globally. Create React app, the tool that sets up everything for us. My React app, that's your project's name. You can change it to anything. It will take a minute or 2 to install. Grab a snack if you like. Once it's done, move into the project folder, cd my React app, then start the app, npm start. Boom. Your default browser should open and show something like edit/app.js and save to reload. And the heart of any React application. Components. React apps are made up of small building blocks called components. They're like reusable pieces of code that return UI. There are two main types: functional components, class components. Let's start with the most commonly used one, functional components. Step 1. Open your project folder in Visual Studio Code. In the terminal at the bottom, make sure your development server is running. npm start. Once it starts, go to your browser and open localhost 3000. You'll see your React app live and ready. Functional component. Now inside the src folder, create a new file. Call it welcome.js. Type this: JSX import React from React. Function welcome, return -h1 welcome to React h1. Export default welcome. This is a functional component. It's just a JavaScript function that returns some JSX. Now let's display it. Open app.js, remove everything inside the return block, and update the code like this: JSX import React from React, import welcome from -welcome, function app, return div welcome div, export default app. Save the file. Now switch to your browser. Boom, you'll see, welcome to React. That's our first working component. Now let's look at the older but still important class component. Create another file, welcome class. Type this: JSX import React component from React. Class welcome class extends component render, return h2. This is a class component. Export default welcome class. Notice the difference? Here we're using a JavaScript class that extends component. It has a render method which returns the JSX. Now let's display this one too. Go back to app.js and import it. JSX import welcome class from /welcome class. Then inside the return block, just add JSX welcome class. Final app.js should look like this: JSX import React from React, import welcome from /welcome, import welcome class from /welcome class. Function app, return div welcome, welcome class div, export default app. Save and check your browser. You'll see both. Welcome to React. This is a class component. That's it. You've now created and rendered both functional and class components in React. Functional components are preferred these days because they're cleaner and support hooks, which we'll learn very soon. Props and event handling. Let's dive in, nice and easy. First, open your project in Visual Studio Code. Head over to the search folder, and inside it, let's create a new file. Right-click New File, name it greeting.js. In greeting.js, write this: JSX import React from React, function greeting props, Return h2 hello, props name h2, export default greeting. Props, short for properties, let us pass data to components. In this case, we're using props.name to display a name. Now go to app.js and update it like this. JSX import React from React, import greeting from /greeting. Function app, return div greeting name code with me viewer div. Export default app. Save the file and check your browser at localhost 3000. You should now see, hello React Learner. Hello Code with Me Viewer. And just like that, we used props to pass custom values to a component. Props make our components flexible and reusable. Now let's move on to event handling, responding to user actions like clicks. Inside the same sarsarc folder, create another file, clickbutton.js. Import React from React. Function click button. Function handle click. Alert, you click the button. Return button on click, click me, the button. Export default click button. The handle click function runs when the button is clicked. This is called an event handler. Now open app.js and import click button. JSX import click button /click button. And in the return block, JSX click button / save it and try clicking the button in your browser. You'll see an alert that says, you clicked the button. Nice job, you just learned how to use props to pass data into components. Use event handlers to make your app interactive. We'll use these again and again in every React project you build. If you're learning something new, hit that like button and subscribe to Code with Me. State, for holding and updating data in components. Conditional rendering, to show or hide content based on logic. Let's get hands-on and understand them in action. Make sure your React app is running. Now in your Visual Studio Code, head to the sarsc folder. Create a new file, counter.js. Right-click, New File, counter.js. Import React, useState from React. Function counter, const count set count equals useState 0. Return div style equals text align center. Current count button on click will set count counts 1. Increment button set count counts 1 decrement. Export default counter. Let's understand this. We're using the useState hook. This gives us a state variable called count and a function setCount to update it. When we click the increment or decrement button, we change the state. React automatically re-renders the component with the new value. Now go to app.js and import the counter component. JSX import counter from /counter. And inside the return block, add JSX counter/. Save everything and open your browser at localhost 3000. Try clicking the buttons. You'll see the count go up and down. That's the power of state, live updates without refreshing the page. Now let's make this smarter using conditional rendering. Still inside counter.js, below the buttons, add this. JSX count equals 0, and then the count is 0. Count 0 and the count is positive. Count 0 and the count is negative. Let me explain. We're using JavaScript logic directly inside JSX. If the condition is true, the element is shown. If not, it's ignored. Try setting the count to 0, then to a positive number, then to a negative number. You'll see different messages based on the value. This is conditional rendering. You can use it to show different buttons, alerts, messages, even entire sections, all based on your logic. And that's it for this video. You now understand how to use useState to manage local data, how to show or hide things using conditional rendering. This is a huge step forward. Most real-world apps rely heavily on both of these features. If you're enjoying the journey so far, like the video and hit subscribe to Code with Me, how to display a list of items in React, what are keys and why they matter, how to build forms and handle user input using state. Make sure your app is running. All right, open Visual Studio Code. Go to your SRC folder and create a new file, itemlist.js. Let's start by rendering a simple list. Write this inside itemlist.js. Import React from React. Function itemList. Const items equals HTML, CSS, JavaScript, React. Return div h2 technologies items.map item index item div. Export default item list. Here's what's happening. We have an array called items. We use .map to loop through the array and render li elements. Each item gets a unique key. In this case, we're using the index. Keys help React track and update list items efficiently. Always try to use a unique ID as a key if you have one, but index is okay for simple lists. Now, open app.js. Import this component, JSX import item list from -item list, and add it inside the return. JSX item list, save it. Head to the browser. You'll see a list of technologies appear. Awesome. Now let's learn how to handle user input. Create a new file, userform.js. Here's a simple input form. Import React, useState from React. Function userform, const username set username equals useState. Function handle change event set username event.target.value. Function handle submit event event.prevent default. Alert welcome username set username. Return form on submit equal handles label. Enter your name, input type will text value username, on change equal handle change. Button type submit, submit button in form. Export default user form. Let's break it down. We're using useState to store the input. The input value is controlled by React. This is called a controlled component. On every keystroke, we update the state. On form submit, we show an alert with the entered name and reset the input. Now back in app.js, import this, JSX import userform from /userform, and include it. JSX userform, save the file. In your browser, type your name and hit submit. Boom, the alert shows your name and the field resets. That's controlled input in action. How to lift state up so different components can share and control the same data. Let's start coding. Part 1, component composition. Inside your *c folder, create a file called card.js. Here's a simple reusable component. JSX import React from React, function card, title, content. Return div style equals border 2px solid 222, padding 16px, margin 12px, border radius 8px, background color F9 F9, H3 content div. Export default card. This component takes title and content as props. It returns a styled box, a card, reusable anywhere in your app. Now create another file, dashboard.js, JSX import React from React, import card from /card, function dashboard, return div dashboard, card title, profile content, this is your profile section. Card title, settings content, update your preferences here. Card title, messages content, you have 5 new messages. Export default dashboard. Here, we're composing the UI by using card multiple times with different props. Open app.js, import JSX import dashboard from dashboard, and render it, JSX dashboard. Save and go to the browser at localhost 3000. You'll see your dashboard with multiple cards. This is component composition. Each component does one job, and together they build the UI like a team. Part 2, lifting state up. Now let's say we want 2 components to share the same state, like a parent and child controlling a single counter. Let's create a new file, counterparent.js. Write this, JSX import React useState from React, import display from /display, import controls from .controls, function counterparent, const count set count equals useState 0, return div style text align center, shared counter, display value count, controls on increment set count count plus 1, on decrement equals set count count is 1 div, export default counterparent. Now create display.js. Import React from React, function display value, return h3 current counting, export default display. And controls.js. Import React from React, function controls, on increment, on decrement. Return button on increment, increment, button on click, on decrement, decrement button. Export default controls. What's happening here? Counterparent holds the state, display shows the value, controls changes the value. We've lifted the state up to the common parent so both components stay in sync. In app.js, replace the current component with JSX import counterparent from /counterparent. Save. Open your browser. You'll see the count and the buttons managed across different components. This is the React way. Keep logic where it belongs and pass props down to build clear, reusable UIs. These 2 concepts will make your apps scalable and clean. If you're learning something new, give this video a thumbs up and subscribe to Code with Me for more React magic. We're going to talk about something every developer should care about, reusability and the DRY principle. What's DRY? Don't repeat yourself. That means write code once and reuse it. React makes that super easy. Let's understand this with a real example. Open your project and let's create a new file inside src/components called button.js. Here's what we'll add. Import React from React, function button, label, on-click, color equals blue, return button on-click, style of padding 10px, 16px, margin 6px, background color, color FF, border none, border radius 5px, cursor pointer. Export default button. We've just created a reusable button component. It takes in a label, an on-click handler, and a color. No matter how many buttons you need, this one file will do it all. Now create a new component, actions.js, JSX import React from React, import button from /button. Function actions, const handle save equals alert saved, const handle delete alert deleted, const handle cancel equals alert canceled. Return div reusability example, button label save on click save, color green. Button label delete, on click will delete, color red. Button label click, on handle cancel, color grave. Export default actions. What's happening here? Instead of repeating the same button HTML 3 times, we're using the same button component, passing different props. Now open app.js and render the actions component. JSX import actions from /components/actions. Function app, Return div class name app, actions div. Go to your browser at localhost 3000. Boom, you'll see 3 different buttons doing different things, all coming from one reusable component. This is the DRY principle in action. It's built from one reusable component. Imagine having 50 products. You don't write 50 lines of UI. You just reuse. Reusable components equals cleaner code, faster development, and 0 headache. That's the React way. Build once, reuse forever. The React component lifecycle. Don't worry, I'll break it down so simply that you'll never forget it. React components go through 3 main stages during their life. Mounting, when the component is created and added to the DOM. Updating, when the component is re-rendered due to changes. Unmounting, when the component is removed from the DOM. Let's see all 3 stages in action using the most modern and clean approach. Inside your /components, create a new file called lifecycle-demo.js. Import React, useState, useEffect from React, function lifecycle demo, const count set count equals useState 0. Mounting useEffect called console.log component mounted. Unmounting return equals console.log component unmounted. Updating useEffect equals if count 0 console.log component updated, count changed to count, return div to React lifecycle demo. Current count, button on click it set count 1 increment div. Export default lifecycle demo. Now, inside your app.js, import and render this component. JSX import React, useState from React. Import lifecycle demo from /components lifecycle demo. Function app, const show set show equals useState true. Return div class name app, button on click set show show. Show hide component show component. Show NN lifecycle demo div. Export default app. Now go to your browser at localhost 3000. Click increment, you'll see the update message in the console. Click hide component, and you'll see the unmount message in the console. This is how you tap into different stages of a component's life using React hooks. You'll use this logic when you want to. Fetch data from APIs when the component loads. Add or remove event listeners. Clean up timers or subscriptions when components unmount. Before hooks came around, React used class components, and lifecycle methods were a big deal. Let's understand how lifecycle methods work step by step. In a class component, we manage the lifecycle with special methods. Constructor runs first when the component is created. Component did mount runs once after the component is added to the DOM. Component did update runs after the component updates. Component will unmount runs just before the component is removed. Let's see them in action. Inside your /components folder, create a new file, class lifecycle demo.js. Import React from React. Class lifecycle demo extends React.component. Constructor props. Super props. This to 8, 0. Console.log. Constructor component is being created. Component did mount. Console.log. Component did mount. Component has been mounted. Component did update. Prev props. Prev state. If prevState.count equal this.state.count. Console.log. Component did update. Count updated to this state.count. Component will unmount. Console.log. Component will unmount. Component is about to be removed. Increments. This.setState. Count this.state.count plus 1. Render. Return div class lifecycle demo. Count this.state count. Button on click increment button div. Export default class lifecycle demo. Now open app.js and update it like this. JSX import React, useState from React. Import class lifecycle demo from ./components class lifecycle demo. Function app, const visible set visible equals useState true. Return div class name app, button on click set visible visible. Visible hide component show component. Visible in class lifecycle demo. Export default app. Now head over to your browser at localhost 3000. Click Increment and check your browser's console. You'll see component did update log every time you update the state. Click hide component, and you'll see the component will unmount message. This shows how React tracks your component's journey from creation, updates, and finally removal. Lifecycle methods help us fetch data when the component is ready, respond to prop or state changes, clean up resources like timers or event listeners. But today, we mostly use functional components with hooks. In the last video, we explored class component lifecycle methods like component did mount, component did update, and component will unmount. But today, in modern React, we use functional components. So the big question is, how do we do the same things using useEffect? Let me show you. Let's take our previous example and convert it into a functional component with useEffect. Remember, component did mount useEffect equal component did update useEffect equal dependency. Component will unmount return inside useEffect. Let's code it out. Inside your source C components folder, create a new file, functional lifecycle demo.js. Import React, useState, useEffect from React. Function functional lifecycle demo. Const count, set count, useState 0. / component did mount useEffect. Console log component mounted. / component will unmount return equals console.log component unmounted. Component did update, only when count changes. useEffect, if count 0, console.log component updated, count is count. Count, return div, functional lifecycle demo. Count, button on click it, set count, count 1. Increment, export default functional lifecycle demo. Now in app.js, replace the previous import with JSX import functional lifecycle demo from /components functional lifecycle demo. And make sure your app shows the component toggle just like before. JSX function app const show set show equals useState true. Return div class name app button on click set show. Show hide component show component. Show and functional lifecycle demo div. Now go to your browser at localhost 3000. When the page loads, check the browser console. You'll see component mounted. Click increment a few times. Now you'll see component updated. Click hide component and boom, you'll see component unmounted. So simple, right? Let's break it down one more time. useEffect. This runs only once when the component mounts, like component did mount. useEffect, count. This runs every time the count changes, like component did update. Return. This cleanup function runs before the component disappears, just like component will unmount. With just one hook, useEffect, you can do everything that those older class methods did. And it's way cleaner. That's why modern React developers love functional components. Hooks completely change the way we write React. No more confusing class components. No more worrying about this, just functions and hooks. It's clean, powerful, and easy to manage. All right, let's explore all the major hooks, step by step, and learn how and where to use each one. useState, the very first hook you'll meet. It lets you add state to a functional component. Const count, set count equals useState 0. Every time set count is called, your component re-renders with the new value. Perfect for tracking clicks, inputs, toggles, anything that changes over time. Want to run code when your component mounts, or after it updates, or even when it unmounts? useEffect, console.log component mounted. Return console.log component unmounted. You can use it for things like fetching data, subscribing to events, updating the DOM ears. It replaces all the class lifecycle methods. Tired of passing props down 4 or 5 levels? useContext gives your component direct access to shared values like themes, user info, or app settings. First, create a context. JSX const theme context react.create context. Wrap your app with the provider. Theme context.provider value dark. App. Theme context.provider. Then anywhere in your app, JSX const theme equals useContext theme context. No more prop drilling. Use reducer. When state becomes complex, like managing multiple values or actions like in Redux, use reducer gives you better control. JX const state dispatch equals use reducer initial state. Perfect for multi-step forms, toggles, custom logic. Think of it like a mini Redux just for your component. Use ref. Need to access a DOM element directly or store a value that doesn't cause re-renders? JSX const input ref equals useRef null. Use it to focus an input, store timers, track previous values. useEffect input ref.current focus. Use memo helps you remember expensive calculations so they don't rerun every render. Const expensive value equals use memo. Return compute something data. Only recalculates when data changes. Boosts performance, especially when rendering large lists. Use callback keeps your functions from being recreated on every render. Const handle click equals use callback console.log clicked. It's especially useful when passing functions to child components. Use layout effect, just like useEffect, but it runs before the browser paints. Use it only when you need to measure DOM sizes or make visual changes before the screen updates. Most of the time, useEffect is better. Use imperative handle. Use this with forward ref to expose certain methods or values to a parent component. Let's say you want a parent to be able to reset or focus a child input. Use imperative handle ref, focus, input ref.current top focus. Rarely used, but powerful in custom component libraries. UseID, use transition, use deferred value. These are newer React hooks. UseID creates a unique ID for accessibility. Use transition keeps UI responsive during big updates. Use deferred value delays updates to avoid blocking rendering. These are mostly for advanced optimization and smooth UX. Custom hooks. The real magic. You can create your own hooks by combining other hooks. For example, JSX function useWindowWidth. Now you can use useWindowWidth anywhere in your app. Custom hooks help you reuse logic in a clean and modular way. That's a lot of hooks, right? React is all about components, little reusable pieces of your app. But as your project gets bigger, some components start doing too much. They fetch data, manage state, render UI, handle clicks, show loaders, all in one place. That can get messy, hard to test, and tough to update later. That's where component patterns come in. Component patterns are just smart ways of organizing your components. They help you split logic and UI, improve reusability, and make your code easier to read and maintain. One of the most commonly used patterns is the container and presentational components pattern. And that's what we're learning today. A presentational component is all about the visuals. It's focused only on how things look. It receives data and event handlers as props and simply displays them. It doesn't manage state. It doesn't fetch data. It just presents. A container component is in charge of how things work. It handles state, data fetching, and logic. Then it passes everything down to the presentational component. Let's jump into some real code. Open your React project. Inside the src folder, create a new folder called Components. Now create two files inside it, userlist.js, userlistcontainer.js. First, let's write the presentational component. Port React from React, function userlist, users, on user click, return div h2 userlist h2, users.map, user le key user id, on click on user click, user name if. Export default user list. Nice and simple. This component just shows the user list. It doesn't care where the data came from or what to do when someone clicks, it just renders. Now let's write the container component, userlistcontainer.js, JSX import React, useState useEffect from React, import userlist from mot/userlist. Function userlist container, const users set users equals useState, useEffect, const fetch users equals async, const response equals await fetch htfetch, json placeholder.typico.com/users, const data equals await response.json, set users data, fetch users, const handle user click equals alert you clicked on user.name, return userlist users users on user click equals handle user click. Export default userlist container. This component handles all the work. It fetches data, stores it in state, and defines what happens when you click a user. Then it passes all that into the userlist component. Perfect separation of logic and presentation. Now let's plug it into our app. Open app.js and add this. JSX import React from React. Import userlist container from /components userlist container. Function app. Return div h1, welcome to code with me, userlist container /div. Export default app. Save your files. Now go to your browser and open h/localhost 3000. You'll see a list of users from the API. Click on any name, and you'll see a pop-up with their name. That's it. Imagine you're building a custom dropdown, or a tab system, or a modal. You don't want to hard-code every part, right? You want your users, or maybe you later, to have control over what goes inside, while still keeping all the behavior and logic bundled. That's exactly what compound components are for. They let you split a component into smaller parts that all work together without manually passing props all over the place. Let's understand this with a fun and real example. We'll build a toggle component with a button that shows and hides some content. But instead of writing one big file, we'll split it into small components that live inside one parent using the compound component pattern. Let's code it out. In your React project, go to the src/components folder. Create a new file called toggle.js. Here's how our compound component structure will look. Toggle, toggle.button, toggled on. Now you see me, toggle off. Now you don't, toggle off. Nice and clean, right? Let's build it. Open toggle.js and write this. Import React, useState, create context, use context from React. Const toggle context equals create context. Function toggle, children. Const on, set on equals useState, false. Const toggle equals set on prev equal prev. Return, toggle context.provider value a toggle, children, toggle context provider. Function button, const toggle equals use context, toggle context. Return button on click toggle, toggle button. Function on children, const on equals use context, toggle context. Return on, children null. Function off, const on use context, toggle context. Return on, children.button equals button. Toggle.on equals on. Toggle.off equals off. Export default toggle. Let's pause here. This component uses a React context behind the scenes to manage state and share it between its subcomponents without passing props manually. Each child, like toggle.on or toggle button, knows about the toggle state through that shared context. Now let's use it in app.js. Open your app.js file and add this. Import React from React. Import toggle from /components toggle. Function app. Return div styling 40ph1. Welcome to Code with Me. Toggle, toggle.button, toggle on. The toggle is on. Toggle off. The toggle is off. Toggle off. Toggle div. Export default app. Now hit save and go to your browser. Visit http://localhost 3000. You'll see a toggle button and text that changes when you click it. Click once, it says the toggle is on. Click again, now it shows the toggle is off. All the logic lives in the parent toggle component, and each piece is neatly handled by a dedicated child. What are controlled components? In React, a controlled component is one where the form data is controlled by React state. This means React is in charge of keeping track of the input value, and whenever the value changes, React updates the state. Think of it like this. You're telling React, I'll control what's in that input field. Example of a controlled component. Let's look at an example, a simple text input. First, create a new file inside your src/components folder called controlledinput.js. Here's what we'll write in it. Import React, useState from React. Function controlled input, const input value, set input value equals useState. Const handle change eventy, set input value, event.target value. Return div h controlled input type text value equals input value, on change equals handle change. You typed input value in div. Export default controlled input. Let's break it down. We use useState to keep track of the input value in the state. The input element's value is set to input value, meaning React is controlling the input's value. Every time you type something, the onChange event fires, and the handle change function updates the state with set input value. So the state is the single source of truth for the input's value. What are uncontrolled components? Now let's talk about uncontrolled components. In contrast to controlled components, uncontrolled components let the DOM handle the form data. React doesn't manage the value of the input. Instead, it lets the browser keep track of the input's value, and React accesses it only when needed. Think of it like this. React says, I won't control that input field, the browser will. Example of an uncontrolled component. Let's create another file in /components called uncontrolledinput.js. Here's the code. Import React, use ref from React. Function uncontrolled input, const input ref equals use ref. Const handle submit equal event equals event.prevent default. Alert you typed input ref.current value. Return div uncontrolled input, form on submit ilfmit, input refix input ref, type text, button, submit. Export default uncontrolled input. Let's break this down too. We use useRef here to create a reference to the input field. When the form is submitted, we use input_ref.current.value to access the value of the input field directly from the DOM. Notice that we're not using useState here. React is not in charge of keeping track of the input's value. The DOM is handling it, and we're just reading the value when we need it. Okay, so when should you use controlled components, and when should you use uncontrolled components? Controlled components are usually the way to go for most use cases. They give you more control over the input, and since React manages the state, you can easily validate and manipulate data before submission. Uncontrolled components are useful when you don't need to keep track of the input value, or when you're integrating with third-party libraries that use the DOM directly. For most cases, especially when you're dealing with forms, controlled components are the better option because they fit nicely with React's declarative nature. Let's check this out in action. 1. Open your app.js. 2. Import both components. JSX import React from React. Import controlled input from /components controlled input. Import uncontrolled input from /components uncontrolled input. Function app return div h1 welcome to code with me uncontrolled input div. Export default app. Save your files and go to your browser at http://localhost 3000. You'll see both controlled input and uncontrolled input components. For the controlled input, type something and the text below it will update in real time. For the uncontrolled input, type something and hit submit. You'll see an alert with the input value.
What is a render prop? In simple terms, a render prop is a technique for sharing code between React components using a function that returns JSX. It's called render prop because we pass a function as a prop, usually named render or children, and that function is used to tell the component what to render. This helps us reuse logic across multiple components without duplicating code. Let's see how that works with a real-world example. Let's build something fun. A component that tracks mouse position on the screen and shares that logic with anything that needs it. Inside your sr/components folder, create a new file called mousetracker.js. Here's the code. Import React, useState, useEffect from React. Function mousetracker render. Const position set position equals useState, x0y0. useEffect. Const update position equals e. Set position x e client x y.client y. Window.add event listener mouse move update position. Return window.remove event listener mouse move update position. Return div style deviation. Export default mouse tracker. Let's pause and understand this. This component tracks the mouse position using useState and useEffect. It accepts a render prop, which is a function. Instead of directly rendering something itself, it calls the render function and passes the mouse position to it. This way, we're keeping the logic inside mousetracker and allowing whoever uses it to decide what to display. Now use it in app.js. Open your app.js file and update it like this. JSX import React from React. Import mousetracker from /components mousetracker. Function app return div dev h1. Welcome to code with me. Mousetracker render equals xyh2. The mouse position is xy div. Export default app. Here's what's happening. We use the mousetracker component. We pass a render function to it. That function receives x and y and returns a simple JSX element that displays the coordinates. Move your mouse around the screen and you'll see the position update in real time. That's the magic of render props, sharing logic cleanly. Where is this useful? Render props are especially useful when you need to share complex behavior, like tracking mouse, detecting screen size, or handling scroll position across multiple components, but you don't want to repeat code. Instead of wrapping everything in how-sees or adding hooks to every component, you keep the logic centralized in one place and pass it down through a render function. It also gives the child component full control over what to display. Naming render props. You don't always have to name the prop render. You can also use children because in React, children can be a function too. Example, JSX mouse tracker xy equals mouse is at x, y mouse tracker. This does the exact same thing, just using children instead of render. Totally up to you and your team's coding style. Should you still use render props? Yes, but sparingly. Since React introduced hooks, we often handle shared logic using custom hooks, which are cleaner in many cases. But render props are still a great tool to have in your toolkit, especially when you need that extra flexibility, or when you're working with class components or legacy code bases.
Higher order components. A higher order component is a function that takes a component and returns a new component. It's a pattern used in React to reuse logic between components without repeating code or changing the original components. So instead of copying the same logic into multiple components, we create one wrapper that adds functionality and reuse it wherever we need. Let's see it in action. Go ahead and create a file in your SRC folder called withcounter.js. Here's our higher order component. Import React, useState from React. Function withCounter, wrapped component, return function enhanced component props. Const count set count equals useState 0. Const increment equals set count prev plus 1. Return wrapped component count increment props. Export default with counter. Let's break this down. We have a function withCounter that accepts a wrapped component. Inside, it manages count state and an increment function. Then it returns the original wrapped component, passing count, increment, and any other props it receives. That's our reusable logic in one place. Now, let's use it. In your SRC components folder, create a new file called clickcounter.js. Import React from React. Import withCounter from /withCounter. Function clickCounter count increment. Return button on click count times button. Export default with counter click counter. And now another one, hovercounter.js. Import React from React. Import with counter from /withCounter. Function hoverCounter count increment. Return h2 on mouse over hovered count times. Export default with counter hoverCounter. Both components, clickCounter and hoverCounter, are wrapped with withCounter. They both get the same counting logic without writing it twice. Now open your app.js and update it like this. JSX import React from React. Import clickCounter from /components/clickCounter. Import hoverCounter from /components hoverCounter. Function app, return div style padding 40px. Welcome to Code with Me, hoverCounter. Export default app. Save the file and open your browser at h//localhost-3000. Now try clicking the button and hovering the text. Boom, both work perfectly, and the logic is reused. This is the beauty of higher order components. They let us share stateful logic between components in a clean, reusable way. A few things to note. The wrapped component receives the enhanced props, plus anything else we pass manually. How-sees don't modify the original component, they wrap it. They're great for adding behavior, like authentication, counters, logging, themes, and more. So what is prop drilling? Prop drilling happens when you have to pass data through multiple levels of components. Even if some of those components don't need the data themselves, you're just passing props down and down and down until it finally reaches the component that needs it. It works, but it becomes messy, especially as your app grows. Let me show you what it looks like. In your React app, go to your SRC folder and create a new folder called Drill Example. Inside it, create 3 files, parent.js, child.js, and grandchild.js. parent.js, import React from React, import child from /child, function parent, const username equals codemaster, return div h2, I'm the parent, child username, export default parent. Import React from React, import grandchild from /grandchild, function child username, return div h3, I'm the child, grandchild username equals export default child. Grandchild.js, JSX import React from React, function grandchild, username, return I'm the grandchild, hello, username, export default grandchild. Now in your app.js, import the parent component. Import React from React. Import parent from /drill-example/parent. Function app. Return div stylo padding 40px. h1 prop drilling demo. Export default app. Open your browser and go to /localhost 3000. You'll see prop drilling demo. I'm the parent, I'm the child, I'm the grandchild. Hello, Codemaster. Pretty cool, right? But here's the issue. The child component didn't even need the username, but it had to receive and pass it just to get it to the grandchild. As your app gets deeper, this becomes annoying and error-prone. So how do we solve this? Well, there are a few ways, but let's start with one of the most powerful tools in React: React Context. Let's refactor the same example using Context API to avoid prop drilling. In the drill example folder, create a new file, usercontext.js, import React from React, const usercontext equals react.createContext, export default user context. Now update parent.js to use the context provider. Import React from React, import child from -child, import user context from /user context. Function parent, const username equals codemaster. Return user context.provider value equals username, I'm the parent, context, child, user context provider. Export default parent. Now, remove the prop from child.js. Import React from React, import grandchild from /grandchild, function child, return div h3, I'm the child x3, grandchild div. Export default child. And in grandchild.js, access the context, JSX import React, use context from React, import user context from function grandchild, const username equals use context, user context, return. I'm the grandchild context. Hello, username. Export default grandchild. Save the files, go back to your browser, and everything still works perfectly. But now, no more drilling. The username is passed directly to the component that needs it, thanks to React Context. What are refs? Refs are a way to directly access a DOM element or a React component from outside. Think of it like reaching inside a component to grab or change something manually. Usually, we create refs using useRef in functional components. Here's a quick example. In your sarc folder, open your app.js, replace the code with import React, useRef from React, function app, const input ref will use ref null, const focus input equals input ref.current.focus, return div style equals padding 40px, input ref equals input ref, type of text, placeholder, click the button to focus, button on click of focus input, focus the input button div, export default app, save it. Go to your browser, ht+/localhost 3000. Now click the button, boom, the input automatically gets focused. This is a basic ref. But here's where the problem comes. If you're trying to forward a ref to a child component, by default, React doesn't allow that. If you just try to pass a ref like a normal prop, it won't actually attach to the DOM element. So we need a special technique called forwarding refs. Let's understand this with an example. In your sarc folder, create a new folder called forwarding ref. Inside it, create two files, custominput.js and parent.js. Custominput.js. Normally, you might write a component like this. Import React from React. Function custom input. Return input type text placeholder custom input. Export default custom input. And then in parent.js, import React. Use ref from React. Import custom input from /custom input. Function parent. Const input ref equals useRef null. Const focus input equals input_ref.current.focus. Return div style of padding equals parent component custom input ref equal ref. Button on click focus input, focus custom input, export default parent. Now try running this in app.js. JSX import React from React. Import parent from forwarding ref/parent. Function app, return div parent div. Export default app. Save it. Go to your browser. You'll notice when you click the button, nothing happens. You might even see a warning in the console. Function components cannot be given refs. This happens because custom input is not prepared to handle a ref. So how do we fix it? That's where forward ref comes into play. Let's update custom input.js. JSX import React, forward ref from React. Const custom input equals forward ref props ref. Return input ref equal ref type text placeholder custom input. Export default custom input. Notice that we wrap the function with forward ref. The ref now gets properly attached to the input. Save the file. Go back to your browser. Now when you click the button yes, the custom input gets focused perfectly. We successfully forwarded the ref. We're talking about memoization with React.memo. Let's dive in. First, imagine you have a component that always re-renders, even if its props haven't changed. This is a waste of time, and it can slow down your app, especially when you have a lot of components on the screen. To solve this, React gives us a tool called React.memo. React.memo is like telling React, hey, if the props didn't change, don't bother re-rendering this component. Just use the last result. It's a simple trick, but it can make a huge difference in performance. All right, now let's see it in action. In your SRC folder, create a new folder called memoization. Inside it, create two files, child.js and parent.js. First, in child.js, write import React from React. Function child name console.log child component rendered. Return div style equals margin top 20px3. Child component name if. Export default child. Simple, right? It just displays the name passed from the parent. Now, in parent.js, write import React, useState from React. Import child from /child. Function parent, const count set count equals useState 0. Return div style padding h1. Parent component h1. Button on click, set count count 1. Increment count count. Child name code with me div. Export default parent. Here, we have a counter. Every time you click the button, the count increases, and we're also rendering the child component below it. In app.js, write import React from React. Import parent from /memoization/parent. Function app, return div parent div. Export default app. Save all the files. Now open your browser. ht localhost-3000. Now watch carefully. Click the increment count button. You'll see in the console, child component rendered every time you click it. But wait, we're only changing the count, right? We're not changing the child's name prop at all. Still, the child component re-renders unnecessarily. And that's where React.memo comes in. Let's fix it. Go to your child.js. Instead of exporting like this, export default child. Change it to import React from React. Function child name console.log child component rendered. Return div style margin top 20px. Child component, export default React.memo child. We simply wrap the component inside React.memo. That's it. Save it. Go back to the browser. Click increment count again. You'll notice the count increases, but the child component does not re-render anymore. Check your console. No extra logs for child rendering now. Success. Keep coding and keep shining. Context and state management in React. Let's make it super simple, and you'll never fear it again. All right, imagine you have a small app. You have a parent component and a child component. Passing data from parent to child using props, that's easy. But now, imagine you have a deeply nested structure: parent, child, grandchild, great-grandchild, and so on. Passing props all the way down, it becomes messy, confusing, and frustrating. This is called prop drilling. And that's where Context API comes to the rescue. Context lets you share data globally, without passing props at every level. It's like creating a global store that any component can access easily. All right, let's build one together. In your SRC folder, create a new folder called Context. Inside it, create 3 files: usercontext.js, parent.js, and child.js. First, in usercontext.js, write import React from React, const userContext equals react.createContext. Export default userContext. Here, we are creating a new context object. Simple. Now, in parent.js, write import React, useState from React, import userContext from /userContext, import child from ./child. Function parent, const user_set_user equals useState, code with me learner. Return userContext.provider value user, div styled parent component h1 child div. Export default parent. Here, we wrapped everything inside userContext.provider. We're providing the value of user to all components inside. Now, in child.js, write JS, import React, useContext from React, import userContext from /userContext. Function child, const user equals useContext userContext. Return div style margin top 20px. Welcome, user. Export default child. Here, we're using useContext to access the user value without passing any props manually. So clean and easy. Now in app.js, update it to import React from React, import parent from /context parent. Function app, return div parent div. Export default app. Save everything. Open your browser at /localhost 3000. You'll see welcome code with me learner in the child component. And we didn't pass props through parent-child manually. All thanks to Context API. We're building a global state using Context Use Reducer. Why? Because for apps with multiple components changing shared data, managing state with just useState gets messy. Let's build a simple app where we can add and remove users using a global state. Inside the SRC folder, create a new folder, context/. In that folder, create 3 files: usercontext.js, userreducer.js, userprovider.js. Let's work on them one by one. In usercontext.js, import create context from React, const userContext equals create context. Export default user context. In userreducer.js, export const initial state equals users. Export const user reducer equals state action. Switch action.type. Case add user. Return .state users state.users action.payload. Case remove user. Return state users state.users.filter user equals action.payload. Default return state. Here, we define actions to add and remove users. Now in userprovider.js, import React use reducer from React. Import user context from /userContext. Import user reducer initial state from ./user reducer. Function user provider children. Const state dispatch equals use reducer initial state. Return user context.provider value state dispatch children user context provider. Export default user provider. This wraps our entire app with a provider that gives access to both state and dispatch. Now in app.js, import the provider and wrap your components. JSX import React from React. Import user provider from /context/user provider. Import user list from /components/user list. Import add user from component/add user. Function app return user provider div style padding 40px. Global user manager add user list. Export default app. Create a component/folder and inside it 2 files, adduser.js, userlist.js. In adduser.js, import React, useState use context from React. Import user context from .context/user context. Function add user. Const name set name equals useState. const dispatch equals use context user context. Const handle add equals if name.trim dispatch type add user payload name set name return div style margin top 20px name on change equals set name e.target.value button on click handle add style margin left add user button div export default add user. We use local state to store input and dispatch to update global state. In userlist.js, import React, use context from React. Import user context from /context/user context. Function userlist, const state dispatch equals use context user context. Return ul style to margin top 20pit, state.users.length, no users added yet. State.users.map, map user idx, user, button on clicking. Dispatch, type remove user, payload user, style margin left 10px remove, export default user list. This component reads global users from state and can remove them too. Open your browser and try it out. Type a name, click add user and see it show up in the list. Click remove and it disappears. This is global state in action. Any component anywhere can read and update this user list. Redux. Redux helps you manage global state in a very organized and scalable way, especially for large apps. Now you might be thinking, didn't we already use context for global state? Yes, but Redux gives you way more control, debugging tools, middleware, and separation of concerns. Plus, with Redux Toolkit, it's much easier than it used to be. Let's build a simple counter app using both traditional Redux setup and then using Redux Toolkit. So let's begin. Inside src/, create a folder called redux//. Inside that, create these files: actions.js, reducers.js, store.js. Export const increment equals increment. Export const decrement equals decrement. Export const increment equals type increment. Export const decrement equals type decrement. These are our action types and action creators. Redux reducers.js, JSX import increment decrement actions. Const initial state equals count 0. Export const counter reducer equals state equals initial state action. Switch action.type. Case increment, return count state.count plus 1. Case decrement, return count state.count minus 1. Default, return state. This is our reducer, a pure function that updates state based on action. Redux store.js. Import create store from Redux. Import counter reducer from /reducers. Const store create store counter reducer. Export default store. Here, we created the Redux store using the reducer. Now in index.js, wrap the app state with the Redux provider. JSX import React from React. Import React DOM from React-DOM/client. Import app from /app. Import provider from React-Redux. Import store from ./redux/store. Const root equals React DOM.create root, document get element by id root, root.render, provider store app provider. Now your app has access to the Redux store. In app.js, JSX import React from React. Import useSelector, useDispatch from React-Redux. Import increment decrement from /redux/actions. Function app, const count equals useSelector state equals state.count. Const dispatch equals useDispatch. Return div style padding 40px, text align center. H1 Redux counter H2. Button on click equals dispatch increment. Increment click dispatch decrement. Style margin left 10px, decrement. Export default app. That's it. You now have a fully working Redux counter. Now let's upgrade it using Redux Toolkit. Install Redux Toolkit. Bash npm install at redux.js/toolkit. Delete your old Redux / folder and create a new one like this. Store.js, counterslice.js. Redux/counterslice.js. Import create slice from at redux.js/toolkit. Const counterslice equals create slice, name counter, initial state, count 0. Reducers increment state, state.count 1. Decrement state, state.count equals 1. Export const, increment, decrement, counterslice.actions. Export default counterslice.reducer. Here, create slice automatically generates action types and creators. Redux store.js, JSX import configure store from @redux.js/toolkit. Import counter reducer from /counterslice. Const store equals configure store. Reducer, counter reducer. Export default store. Everything else stays the same. In index.js, you wrap app hatch with the provider. And in app.js, you still use JSX const count equals state.count. Const dispatch equals useDispatch. Redux Toolkit makes state management cleaner and faster to set up. Quick recap. Redux helps manage state globally in large apps. Redux Toolkit simplifies Redux with less boilerplate. Toolkit is now the recommended way to use Redux in React apps. Zustand. Zustand means state in German, and it lives up to its name: clean, minimal, and powerful. If Redux feels too heavy or complicated for your small or medium-sized app, Zustand is a game changer. Let's build a simple counter app, and you'll see how quick and intuitive Zustand really is. First, let's create a new React app. In your terminal, npx create React app Zustand-demo, cd Zustand-demo, npm install Zustand npm start. The app will open your browser at http localhost 3000. Open the project in VS Code. Inside src, create a new folder called store. Inside that, create a file, counterstore.js. Import create from Zustand. Const use counterstore equals create set equal count 0. Increment set state count state.count +1. Decrement count state.counts 1. Export default use counterstore. That's it. No reducers, no actions, just one beautiful minimal store. Let's break it down. Count is your state. Increment and decrement are your actions. Set is Zustand's internal way to update state. Now let's use this store in your app.js file. Import React from React. Import use counterstore from store/counterstore. Function app. Const count increment decrement equals use counterstore. Return style padding 40px text align center. Zustand counter h2. Button on click increment. Button on click decrement. Style margin left 10 peak decrement. Export default app. Save the file and check your browser. Your counter works perfectly, and you didn't even need a provider or any setup in index.js. What makes Zustand so good? No provider, just import the store where needed, global or local. Zustand works both ways. Super fast, no unnecessary re-renders. Lightweight, less than 1 kilobyte. Readable and clean, it feels like writing plain JavaScript. When should you use Zustand? For simple to medium-sized apps, when Redux or context feels like overkill, when you need quick prototyping or isolated logic. Zustand is used by major companies like Meta, Shopify, and others who value performance and simplicity. So that's it, Jotai and Recoil. They're simple, modern, and great alternatives to heavy libraries like Redux. Let's break them down one by one and build real examples so you see how they work in action. Part 1, Jotai, atomic state for React. Jotai means atomic in Japanese, and that's how it works. It manages your state like atoms, tiny, isolated, and composable. Let's create a quick app using Jotai. First, create a new React app. npx create React app Jotai demo cd Jotai-demo npm install Jotai. npm start. Now, open your project in VS Code. Inside / create a new file, src store.js. Import atom from Jotai. Export const count atom equals atom 0. Now go to app.js. Src app.js. Act from React. Import use atom from Jotai. Import count atom from /store. Function app. Const count set count equals use atom count atom. Return div style equals text align center. Padding 40px. h1 tie counter. Button on click. Set count. Counter button. Button on click. Style margin left 10px. Decrement. Export default app. Open your browser at localhost 3000. Boom, your counter works. No provider, no reducer, no boilerplate. Jotai keeps things simple and local, but you can also build big apps with it using derived atoms and async atoms. Part 2, Recoil, Facebook's approach to state management. Recoil was developed by Meta, designed for large-scale apps with shared and derived state. Let's create a Recoil app. npx create React app, Recoil demo. cd Recoil demo m install Recoil. npm start. Now open the app in VS Code. sr/store.js. Import atom from Recoil. Export const count state equals atom, key, count state, default 0. Now update your app.js. Import React from React. Import Recoil root, use Recoil state from Recoil. Import count state from /store. Function counter, const count set count equals use Recoil state count state. Return div styling center padding 40p h1. Recoil counter h2. Count button on click set count counts 1. Increment button on click set count count nice 1. Style margin left 10px. Function app, return Recoil root counter Recoil root. Export default app, Recoil suitor needs a provider. That's the Recoil root. Everything else feels like React, and that's the beauty of it. Jotai or Recoil, which should you use? Jotai, perfect for small to medium apps, minimal setup, clean syntax, best for atomic, local state. Recoil, better for complex apps where state needs to be shared across many components. It supports selectors, derived state, and async data very well. Both are solid. Pick the one that fits your project size and complexity. So, whether you're building a simple counter or a complex dashboard, Jotai and Recoil are two great tools in your React toolbox. So far, we've worked with Redux to manage state in a predictable way. But what happens when your app needs to handle things like API calls, delayed actions, or even background tasks? That's where Middleware comes in, and two popular ones are Redux Thunk and Redux Saga. Today, we'll understand what they do, how they work, and when to use them. Let's start with the basics of middleware. Think of middleware as a middleman sitting between the action and the reducer. Whenever an action is dispatched, middleware gets a chance to intercept it, perform logic, and either allow it to continue or dispatch something else. Now let's look at Redux Thunk. Thunk allows us to return a function instead of a plain object in our action creators. That function can be async, and inside it, we can dispatch multiple actions. Great for API requests. Let's set it up step by step. Create a new app. npx create React app, Redux Thunk-demo, cd Redux Thunk demo, npm install Redux, React Redux, Redux Thunk. Inside src/ create a store.js. Import create store, apply middleware from Redux. Import Thunk from Redux-Thunk. Const initial state equals loading false, data, error null. Const reducer, state equals initial state action. Switch action.type. Case fetch start, return state loading true. Case fetch success, return state loading false, data action.payload. Case fetch error, return state loading false, error action.payload. Default, return state. Const store equals create store reducer, apply middleware Thunk. Export default store. Now let's create an async action to fetch data from an API. src/actions.js. JS export const fetch data equals return async dispatch equals dispatch type fetch start. Try const response equals await fetch hbs json placeholder.typico.com/posts. Const data equals await response.json. Dispatch type fetch success payload data. Catch error dispatch type fetch error payload error message. Now wire it up in your main app. Sarf app.jsx import React useEffect from React. Import use dispatch use selector from React-Redux. Import store from /store. Import provider from React Redux. Import fetch data from /actions. Function posts const dispatch equals use dispatch. Const loading data error equals use selector state equals useEffect. Dispatch fetch data dispatch. Return div style padding 4h1 Redux Thunk example loading and unloading. error, and in p-style color red, error. Data.map post div key equals post.title div. Function app, return provider store equals store posts provider. Export default app. Open the browser at h/localhost 3000, and boom, you just fetched and displayed data using Redux Thunk. Now let's talk about Redux Saga. Sagas are more advanced. They work using generators and side effects. Saga helps keep complex async flows organized, like chaining calls, handling cancellation, or even delays. If you prefer structured, testable, and declarative flows, Saga is your friend. Here's a short overview. Bash npm install Redux Saga. You'd create a saga like this, sr sagas.js. JS import call put take every from redux-saga/effects. Function fetch posts. Try const response equals yield call fetch hjson placeholder.typico.com/posts. Const data yield call response JSON. Yield put type fetch success payload data. Catch E. Yield pipe fetch error pay.message. Export function root saga. Yield take every fetch start fetch posts. Then you'd configure it with create saga middleware, just like we did with Thunk. Saga is like running a background worker. It's powerful, but best suited for larger apps. We're going to style our React apps using two powerful and commonly used methods, CSS module and CSS or Sass. Let's dive right into the first one, CSS modules. CSS modules in React. CSS modules help you write CSS that is scoped locally to the component, preventing class name collisions. Inside your src folder, create a new file called app.module.css. CSS.title, color, FB056, font size 2 rem, text align center, margin top 50px, font family Sego UI sans serif. Now open app.js and import the CSS module like this. Import React from React. Import styles from app.module.css. Function app, return h1 class name equals styles title. Styled with CSS modules 1. Export default app. Save the file and open your browser at localhost 3000. You'll see the heading styled in pink with centered text. That's CSS modules in action, clean and modular. SCSS, or Sass, in React. SCSS is a CSS preprocessor that allows variables, nesting, mixins, and more. Before using SCSS, we need to install the Sass package. In your terminal, run npm install Sass. Now, let's style the component using SCSS. Rename your app.module.css to app.module.scss. Update the SCSS code inside. Update the import path in app.js. JSX import React from React. Import styles from app.module.scss. Function app, return h1 class name called title styled with SCSH1. Export default app. Once you save the files, go back to the browser, hover over the text, and you'll see it darken slightly. That's your SCSS variable and nesting in action. That's how you can style your React components using CSS modules and SCSS. Both approaches are clean, scalable, and production ready. Styled components and emotion. These are modern tools that help us write CSS directly inside our JavaScript files. And trust me, they make styling components clean and organized. Let's start with styled components. Open your terminal and install styled components. Bash npm install styled components. Once installed, open your React project, for example, inside src-app.js. Now import styled like this. JS import styled from styled components. Let's create a styled heading and a styled button. JSX/app.js, import React from React. Import styled from styled components. Const title equals style.h1. Color FB 2.5 rem, text align center, margin top 40px. Font family Sego UI sans serif, and hover color tabard da1c4b. Const styled button equals style.button. Background conf56, color white, border none. Padding 12px, 24px. Border radius 8px. Cursor pointer, margin top 20px. Font size 1 rem. And hover, back color da1c4b. Function app, return div style text align center. Hello from styled components. Click me. Export default app. Save the file. Then in your browser, go to http:/localhost3000. You'll see a beautifully styled heading and button. Hover over them and watch the colors change. All of this is handled inside the component. No external CSS files needed. Part 2. Emotion. First, install Emotion by running this in your terminal. Bash npm install emotions react add emotions styled. Then open app.js again and modify the code like this. JSX @JS import source add emotions react. Import react from react. Import styled from add emotion/styled. Const title.h1 color FB2056. Font size 2.5 rem. Text aligned center. Margin top 40px. Font family Sego UI sans serif. And hover color day1c4b. Const emotion button equals style.button. Background color FB2056. Color white. Border none. Padding 12p24px. Border radius 8px. Cursor pointer. Margin top 20px. Font size 1 rem. And hover. Background color day1c4b. Function app. Return text align center. Hello from Emotion. Click me. Export default app. Remember, for Emotion, make sure to include this comment at the top of the file. JSX import source add emotions react. Save and reload your browser. Now the exact same design works using Emotion. You can use either Emotion or styled components depending on your preferences. Both are awesome. Inline and dynamic styles. Dark and light theme switching. Let's jump in. Part 1. Inline and dynamic styles. Inline styling in React means you add the CSS styles directly to the element using the style prop. Let's open up our app.js and start coding. Import React, useState from React. Function app. Const is active, set is active equals useState false. Const heading style equals color is active, FB2056 tar333. Font size 2 rem, text align center. Margin top 40px. Font family Arial sans serif. Transition all 0.3 SEs. Const button styles. Background color is active, FB2056. Color white, border none. Padding 10px 20px. Margin top 20px. Cursor pointer, border radius 8px. Font size 1 rem. Return div style text align center. Is active, active style applied. Default style applied. On click, set is active. Toggle style button div. Export default app. When you run this on hlil/localhost3000, you'll see the text and button change styles based on whether is active is true or false. That's called dynamic inline styling. Very useful when you need quick conditional styles without importing any extra CSS. Part 2. Dark and light theming. Let's now create a basic theme switcher that toggles between light and dark mode. We'll use simple conditional styling based on a theme state. Import React, useState from React. Function app, const set theme equals useState light. Const themes equals light, background color F, color 33333. Dark, background color 1A, 1A, 1A. Color F5, F5, F5. Const current theme equals themes theme. Return stylate 100VH, current theme. Transition, all 0.4 SEs. Display flex, flex direction, column. Align items, center. Justify content, center. H1 welcome to theme switcher. Margin top 20px, padding 10px, 20px. Border radius 8px. Border none. Background color theme equals light, tat FB2056, DA1C4B. Color white. Cursor pointer, font size 1 rem. On click equals set theme light, dark, light. Switch to theme light, dark, light mode button div. Export default app. Save and go to localhost 3000. Click the button to switch between light and dark themes. You'll see the whole page background and text color change smoothly. This is the simplest way to implement theming using just React and inline styles. Routing. When we build multi-page experiences like home, about, contact, we don't actually reload the entire page in React. Instead, we use something called client-side routing. And the tool that powers this is React Router. Let's see how to set it up from scratch. npx create React app React-routing demo cd React routing demo npm install React router-dom. Open the project in your code editor. Navigate to the // folder. We'll begin by creating a few basic components. sr/pages home.js. Function home, return h2, welcome to the home page 2. Export default home. sr pages about.js. JSX function about, Return, this is the About page. Export default About. SR pages contact.js, JSX function contact. Return contact us at codewithme@example.com. Export default contact. Now go to your main file, @app.js. Here's how we use React Router. Import browser router as router, routes, route link from React-router DOM. Import home from /pages home. Import about from pages about. Import contact from .pages/contact. Function app, return router div style padding 20px. Link to = style margin right 10px home. Link to = about style margin right 10 about. Contact. Routes. Route path = about. Route path = contact. Export default app. Now open your browser and go to /localhost 3000. Click on the About or Contact links, and you'll notice that React switches pages without reloading the whole site. That's SPA routing, smooth and fast. Let's now handle a 404 page. Sometimes the user may type a wrong path, so let's catch it. At the bottom of your routes, JSX route path shot element 8204 page not found. Done. Now try visiting localhost 3000 doesn't node exist, and you'll see your custom 404 message. Wait, can we do nested routes too? Yes, say /about, we want a subpage for team. Import link outlet from React-router DOM, function about, return div h2 about us h2, link to team, meet the team link outlet div. Export default about, src/pages/team.js. Function team, return h3 of passionate devs at code with me. Export default team. In app.js, update the route for about, JSX route path = about element, route path team, element t route. Now go to h2/3000/about/team, and you'll see nested routing in action. React Router DOM v6+, the official routing library for React. Routing means controlling which component to show based on the URL, and React Router makes this super clean. Let's build a mini multi-page app and explore everything, from basic routes to protected routes. Setup. Open your terminal and create a project. npx create React app React routing demo, cd React routing demo, npm install React Router DOM, npm start. This launches the app at localhost 3000. Now open the project in VS Code. Create a folder called pages/insource. Inside it, create home.js, about.js, profile.js, notfound.js, and in each file, a simple component. Repeat similarly for about, contact, etc. with different text. In app.js, we'll set up routing. JSX import browser router routes route from React-router DOM. Import home from /pages home. Import about from ./pages/about. Import contact from pages contact. Function app. Return browser router h1 React Router demo routes route path = element = home route path about element about. Route path contact element. Route path element not found browser router. Export default app. This is the heart of routing. Browser router watches the browser URL. Navigation with useNavigate. Pages/home.js. JSX import useNavigate from React Router DOM. Function home const navigate = useNavigate. Return homepage button navigate/about. Go to about. Export default home. Clicking the button changes the route without a page reload. Use location and use params. Update about.js to view the current URL. JSX import useLocation from React Router DOM. Function about const location = useLocation. Return h2 about page. You are at location.pathname. Export default about. Now create a dynamic route. Profile.js, JSX import useParams from React Router DOM. Function profile, const username useParams. Return h2 welcome to username as profile. Export default profile. And update app.js. JSX route path profile /username element = profile. Visit /profile a kill and it dynamically shows nested routes. Create a new folder, Pages Dashboard, inside it, dashboard.js, dashboardhome.js, dashboardsettings.js. Dashboard.js, JSX import outlet link from React router DOM, function dashboard, return div h2 dashboard home link, link to settings link nav, outlet div, export default dashboard, dashboard home.js, JSX function dashboard home, return, this is the dashboard home, export default dashboard home, dashboard settings.js, JSX function dashboard settings, return settings page, export default dashboard settings. Then in app.js, JSX import dashboard / pages dashboard / dashboard. Import dashboard home from .pages / dashboard home. Import dashboard settings from pages dashboard settings. Route path equals dashboard. Route path equal home element dashboard home. Route path settings element dashboard settings. Now go to /dashboard /home or /dashboard settings. Nested routes work using outlet. Protected routes. Let's protect a route. Only show it if logged in. Create private route.js. Import navigate from React router DOM. Function private route is logged in children. Return is logged in children. Navigate to / export default private route. Now in app.js, protect the dashboard. JSX import private route from /components /private route. Route path equals dashboard /dosh elements. Private route is logged in true. Route path home element dashboard home. Route path equals settings elements. Set is logged into false, and you'll be redirected to /. Using navigate, we can programmatically redirect. Example, JSX route path old about element equals navigate to equals /about, replace. Visiting /old about will take you to /about. Hash router versus browser router. If your app is hosted without server support for client-side routing, GitHub pages, use hash router. JSX import hash router from React router DOM. Hash router, routes. It uses URLs like http/localhost 3000/about, useful for static hosting. Data fetching and APIs. You'll learn how to use fetch and Axios, handle async await inside useEffect, work with S2R and React Query, fetch data using GraphQL and Apollo Client, manage loading and error states, and implement pagination and infinite scroll. Let's get started. Creating a React app. Terminal, bash npx create React app data fetching demo, cd data fetching demo npm start. App.js. Clear out the boilerplate. JSX function app. Return div welcome to data fetching demo div. Export default app. Fetch API, the native way. Let's begin with the browser's built-in fetcher function to load some data. Import useEffect, useState from React. Function app, const post set posts equals useState. UseEffect, fetch https on placeholder.typico.com/posts, res.json. Then data equals set post data. Return div posts.map post black title. UseEffect async await. Want cleaner readable code? Let's wrap fetch in an async function. JSX useEffect, const get posts equals async. Const res equals await fetch, https json placeholder.typico.com/posts. Const data equals await rest.json, set posts data. Catch error, console error, get posts. Now let's switch to Axios, a cleaner, more powerful HTTP client. Bash npm install Axios. JSX import Axios from Axios. UseEffect const get posts equals async equals full. Try const res equal await Axios json placeholder.typico.com/posts. Set posts rest.data. Catch error, console error, get posts. useSWR, React hook for data. SWR handles caching, revalidation, and error states out of the box. Bash npm install SWR. JSX import useSWR. Import Axios from Axios. Const fetcher goes URL Axios to get URL. Then resio res.data. Function app. Const data error is loading htjson placeholder.typico.com/posts fetcher. If is loading, return loading. If error, return error occurred. Return div data.map post p-key post id post title. React query, full state management. React query gives us full control over server state. Bash npm install at tanstack/react-query. JSX import query client provider from @tanstack/react-query. Import React DOM from React DOM/client. Import app from /app. Const query client equals new query client. Const root equals react dom.create root document get element by id root. Root.render query client provider client equals query client. Import use query from @tanstack react-query. Import Axios from Axios. Const fetch posts equal axios.get json placeholder.typico.com/posts, then res equals res.data. Function app const data error is loading equals use query, query key, query fn, fetch posts. If is loading, return loading. If error, return error loading data. Return div data.map, post p-key, post id, post.title. GraphQL plus Apollo client. Let's use Apollo client to fetch from a public GraphQL API. Bash npm install apollo/client GraphQL. JSX import Apollo client in memory cache Apollo provider from @apollo/client. Const client new Apollo client. URL/countries.trevorblades.com/cache new in memory cache. Root.render Apollo provider client app Apollo provider. JSX import GQL use query from @apollo/client. Const get countries equals GQL query. Countries code name. Function app const data loading error equals use query get countries. If loading, return loading. If error, return error fetching countries. Return div data.countries.map country key country.code country.nadiv. Loading and error states. Always show users feedback when loading or errors happen. If is loading, return loading. If error, return error loading data. Pagination with API. We'll now fetch only 10 items per page and navigate with a button. JSX const page set page equals useState1. UseEffect equals const fetch posts equal async. Const res equals await axios.get https just json placeholder.typico.com/posts. Limit equals 10 and page score page. Set posts res.data. Fetch posts. Button on clicky set page previv +1. Infinite scroll. We'll use a library to load more data as we scroll. Bash npm install React Infinite Scroll component. Import Infinite Scroll from React Infinite Scroll component. Infinite scroll data length equals posts.length. Next equals fetch more data. Has more loader. Loading. Posts.map post id. Post title. That's it. You now know how to fetch data in React using all modern methods, from basic fetch to GraphQL. Authentication. Yup, that's your login and sign-up system. We'll build beautiful forms, manage user input, handle basic validation, and simulate a login sign-up flow. Let's go. Open your terminal and create a new React app. Bash npx create React app, React auth demo, cd React auth demo, npm start. It should open your browser at /localhost 3000. Now open the project in VS Code. Inside the src folder, create a new folder called Pages. This is where we'll keep our login and signup components. Create two files, login.js and signup.js. Let's start with the signup form. Inside signup.js, write import React, useState from React, function signup, const form data, set form data, useState, username, email, password, const handle change equals set form data, form name, target.value, const handle submit equals prevent default, console.log user registered form data, alert sign up successful, return dpx, form on submit equals handle submit, input type text namebook username, placeholder username value, form data.username, on change handle change. Required. Input type equals email name placeholder email, form data.email, on change handle change. Required. Input type password name password placeholder password value form data.password, on change to a backend. On sign up, export default sign up. This form stores user input in useState. When submitted, it prints the data to console and shows an alert. Of course, in real apps, you'd send this to a backend. Now in login.js, write import React, useState from React, function login, const credentials set credentials equals useState email password, const handle change equals set credentials target.name target.value, const handle login equals prevent default. For now, just simulate login if credentials.email user@example.com and credentials.password 12456. Alert login successful. Else, alert invalid credentials. Return div style padding 30px h to login. Form on submit. Input type email, placeholder email, value credentials.email, on change handle change. Required. Put type password, name placeholder password, value credentials.password, on change handle changer. Button type submit, login, export default login. This is a dummy login. In real life, you'd validate these details with a backend or Firebase. Now, let's wire everything into app.js. Replace the content of app.js with import React from React, import login from /pages login, import signup from /pages/signup. Function app, return div style text-align center, h1, React auth demo, signup, login div, export default app. Save it. Your browser should now show the sign-up form and login form side by side. You can sign up with any details. Login only works if you type user@example.com 123456. Token-based authentication with JWT, also known as JSON Web Tokens. If you've ever wondered how websites keep you logged in or how they protect pages behind a login, that's JWT in action. Let's build a real-world React and JWT login system. You'll understand how the token is generated, stored, and used to access protected routes. You can create a new folder outside your React app. Name it Auth Backend. In your terminal, bash mkdir auth backend cd auth backend npm init -y npm express cores JSON Web Token body parser. Now create a file server.js, js const express, require express, const cores equals require cores, const jw require JSON Web Token, const body parser, require body parser, const app equals express, const port equals 5000, const secret equals your JW secret, app.use course, app.use body parser.json, app.post/login, require const email body, if email equals user@example.com and password 53456, const token equals JWT sign, email secret expires in 1H, return res.json, token, res.status 401 JSON, error invalid credentials, app.get/protected regress, const auth header equals req.headers authorization, const token equals auth header, split token return res.status 403, JSON, error, no token provided, jwt.verify token secret year, if return res.status 403, JSON, error token invalid, res.json, message, protected data, user, app.listen port, console.log, server running on HT localhost port, run it, bash node server.js. Your backend is live at /localhost 5000. Build the React frontend inside your React project. React auth demo. Install Axios, bash npm install Axios. Then update login.js, JSX import React, useState from React, import Axios from Axios, function login, const credentials, set credentials equals useState, password, const token, set token equals useState, const message, set message equals useState, const handle change, set credentials, target name, target.value, const handle login equals async equals prevent default, try, const res equals await axios.post 8/localhost 5000 login credentials, set token res.data.token, local storage.set icon res.data.token, set message login successful, catch error, set message login failed, const access protected equals async, try, const res equals await axios.http localhost 5000/protected, headers authorization bearer dollar token, set message res.data.message, catch error, set message access denied, div style of padding 20px, login with JW handle login, input type of email, name of email, placeholder equals email, on change equals handle change required, input type password, name is word, placeholder password, on change required, button type submit, login button, on click access protected route message, export default login, open app.js and render login kata. In your browser at localhost 3000, you'll see the login form. Use user@example.com 123456. Log in and then hit the access protected route button. You'll see protected data. So what just happened? 1. User enters credentials. 2. We send them to the backend. 3. If valid, backend returns a JWT token. 4. We store it in local storage. For protected routes, we include the token in the authorization header. If the token is valid, you get access. If not, you get blocked. A complete login and sign-up system using Firebase authentication in React. No backend needed. No writing JBTs. Firebase takes care of everything for us. Let's build it. Step 1. Create a new React app. In your terminal, bash npx create React app, React Firebase auth, cd React Firebase auth npm start. Open the project in your code editor. Step 2. Set up Firebase. Now go to console.firebase.google.com. Create a new project. You can name it React Auth app. Once created, click Authentication Get Started. Enable email password sign-in. Now go to Project Settings, General. Scroll to your apps and click Web icon to register a new app. Give it a name like React Firebase Auth and register it. Copy the Firebase config object. We'll need this in code. Step 3. Install Firebase SDK. Back in your terminal, bash npm install Firebase. Create a file /firebase.js, js//firebase.js, import initialize app from firebase/app, import get auth from firebase/auth, const firebase config equals API key, your API key, auth domain, yourprojectfirebaseapp.com, project ID, your project ID, storage bucket, your project.apps.com, messaging sender ID, app ID, D, const app equals initialize app Firebase config, export const auth equals get auth app. Replace the config values with your actual Firebase project keys. Step 4. Create login and signup components. Inside SRC, create a folder called components, and inside it, create login.js and signup.js. Signup.js, import React, useState from React, import create user with email and pass from Firebase/auth, import auth from /Firebase. Function signup, const email set equals useState, const password set password equals useState, const msg set msg equals useState, const handle signup equals async e.prevent default, try, await create user with email and password, auth email password, set and signup successful, catch error, set msg error.message, return div style of padding 20px, h signup, input type email placeholder email, on change equals set email e.target value, input type password placeholder password, on change set password e.target value. Button type submit, sign up button, form div. Export default sign up. Import React useState from React. Import sign in with email and password from Firebase auth. Import auth Firebase. Function login. Const email set email equals useState. Const password set password equals useState. Const MSG set MSG equals useState. Const handle login equals async e equals e.prevent default. Try await sign in with email and password. Auth email password. Set MSG login successful. Catch error set mesh.message. Return div style echo padding 20px. Login. Form on submit email placeholder email on change e equals set email dot target value. Input type of password placeholder password on change set password button type submit login dot target value. Export default login. Step 5, show the current logged in user. Import React, useEffect, useState. Import auth from /Firebase. Import login from ./components/login. Import signup from .components signup. Import on-auth state changed signout from Firebase auth. Function app const user set user equals useState null. useEffect const unsubscribe equals on-auth state changed auth current user set user current user. Return equals unsubscribe. Const handle logout equals signout auth. Return div stylish text align center padding 30px. React Firebase auth user. Welcome user.email. Logout button. Sign up har. Login. Export default app. Now open your browser at h/localhost 3000. Try signing up and logging in. Firebase tracks the session and keeps the user logged in automatically. And that's it. You now have a working, real-world Firebase authentication system in React. Logging in with Google and GitHub using Firebase authentication in a React app. Step 1. Create a React app. Open your terminal and run bash npx create react app react OAuth login cd react OAuth login npm start. Once it's running, open your browser and navigate to localhost 3000. Then open the project in VS Code. Check Step 2, install Firebase SDK. In the terminal, run bash npm install Firebase. Step 3, set up Firebase project. Go to Firebase console, console.firebase.google.com. Click Add Project, name it, e.g. React OAuth. Click Create Project. Click on the web icon to create a web app. Register. Continue. Copy the Firebase config. Step 4. Enable Google and GitHub Auth in Firebase. In Firebase console, go to Authentication, Sign-in method. Enable Google, click Save. Enable GitHub. To get your GitHub credentials, go to GitHub Developer Settings. Click New OAuth App Application Name, React OAuth App. Homepage URLs, localhost 3000. Authorization callback URLs, localhost 3000. Click Register Application. Copy the client ID and client secret. Paste these into Firebase GitHub configuration. Step 5. Create Firebase config file. In your React project, inside the sr/folder, create a file called firebaseconfig.js. Import initialize app from firebase/app. Import getAuth, Google Auth provider, GitHub Auth provider from firebase/auth. Const firebase config, API key, your API key, auth domain, your project ID.firebaseapp.com, project ID, your project ID, app ID. Include the rest from Firebase. Const app equals initialize app, Firebase config. Const auth equals getAuth app. Const Google provider equals new Google Auth provider. Const GitHub provider, new GitHub Auth provider. Export auth, Google provider, GitHub provider. This sets up Firebase with Google and GitHub OAuth providers. Step 6. Add OAuth login UI in app.js. Replace everything in your app.js file with import React from React. Import sign-in with pop-up from Firebase/auth. Import auth, Google provider, GitHub provider from bucked. Firebase config. Function app, const login with Google equals async equals try. Const result equals await sign-in with pop-up auth, Google provider. Const user equals result.user. Alert, welcome user display name. Catch error, alert error message. Const login with GitHub equals async. Try, const result equals await sign-in with pop-up auth, GitHub provider. const user result.user. Alert welcome user to display name. Catch alert message. Return div style a text align center margin top 50px. H1 OAuth login button on click with Google's. Login with Google. Button on click login with GitHub. Login with GitHub. Export default app. Click login with Google. Google sign-in pop-up appears. Try login with GitHub. GitHub sign-in page opens. Approve the app, returns, and shows the username. After setting up OAuth login with Google and GitHub, let's now protect your pages so only logged-in users can access certain routes. This is where private routes come in. What are private routes? Private routes are components that only render if a user is authenticated. Otherwise, redirect users to a login page or show an error. Let's add that logic into our React app. Step 1. Create a context for auth. Inside your // folder, create a new file, authcontext.js. Import React, create context, useEffect, useState from React. Import onAuth state changed from Firebase auth. Import auth from /Firebase config, const auth context. Export const auth provider equal children. Const user set user useState null. Const loading set loading equals useState true. useEffect. Const unsubscribe eats onAuth state change auth current user set loading false. Return is unsubscribe. Return auth context.provider value user loading children auth context.provider. Export const useAuth equals use context auth context. This sets up global access to the user across your app. Step 2. Create a private route component. Create private route.js. Import React from React. Import navigate from React-router DOM. Import useAuth from the auth context. Const private route equals children. Const user loading equals useAuth. If loading, return user, children. Export default private route. This component only renders children if the user is authenticated. Step 3. Set up routing with React Router. Install React Router. Bash npm install React Router DOM. Then update your app.js. Import React from React. Import browser router as router, routes, route from React Router.dom. Import auth provider from /auth context. Import private route from /private route. Import home from /home. Import dashboard from /dashboard. Protected page. Import login from /login. Login UI OAuth function app. Return router auth provider routes. Route path equals login element login. Route path equals /board element cloud dashboard out dashboard routes auth provider. Export default app. Step 4. Create basic pages. Home.js. Import React from React. Import link from React-router DOM. Const home equals div style text align center margin top 50 page. Link to a /login so dashboard. Go to dashboard link of export default home. /login.js. OAuth from earlier. Reuse your existing OAuth code here or extract it from app.js. JSX/sar/login.js. Import React from React. Import sign in with pop-up from Firebase auth. Import auth Google provider, GitHub provider from /Firebase config. Const login equals const login with Google equals async. Try. Await sign in with pop-up auth Google provider. Catch error, alert error.message. Const login with GitHub equals async. Try. Await sign in with pop-up auth GitHub provider. Catch error. Return div style text align center, margin top 50 ph1. Login on click, login with Google. Login with Google button on click, login with GitHub. Login with GitHub div. Export default login. JSX /dashboard.js. Import React from React. Import auth from /Firebase config. Const dashboard equals const handle logouts auth.signout. Return div style text align center margin top 50 px h dashboard only visible to logged in users. Logout button div. Export default dashboard. Go to http:/localhost3000/dashboard directly. You get redirected to /login or / if not logged in. Log in using Google GitHub. Now visit /dashboard. You'll see the protected page. Click logout, back to unauthenticated state. A to-do list app with voice assistant. Using React and the Web Speech API, you'll be able to say your tasks out loud and watch them appear instantly in your to-do list. Let's dive right into it. Open your terminal and type npx create react app voice to do cd voice to do npm start. Now let's build the core of our app, the to-do list. We'll manage our tasks using useState and store them in local storage so they persist on refresh. src app.js. Import React. useState, useEffect from React. Import use voice command from /use voice command. Const app equals. Const task set tasks equals useState. Const input useState. Use voice command task equals set tasks prev id date.now text task done falsy. Const add task equals if input trim return set tasks id date.now text false set input. Const toggle done id set tasks task map tasks task id equal id task done task. Const delete task equals id. Set tasks filter tasks cast.id equals id. useEffect. Const saved JSON parse local storage item tasks. Set tasks saved. useEffect. Local storage.set item tasks JSON stringify tasks. Tasks. Return div class named app h1 voice controlled input type text value input. Placeholder add a task on change set input target value on key down key equals enter and add task. Button on click add task. Tasks.map t like ti style text decoration line through none not text button link. Toggle done delete task titan. Try saying add task call mom div export default app. Now let's add the voice control magic. We'll use the Web Speech API to recognize voice input and convert it to tasks. src/use voice command import useEffect from React. Const use voice command equals on command detected equals useEffect. Const speech recognition equals window.speech recognition window.webkit speech recognition. If speech recognition return. Const recognition is new speech recognition. Recognition.continuous equals true. Recognition.lang equals enus. Recognition.onResult equals event rules, and const transcript equals event.results of event results.length 0 transcript.trim. If transcript.to starts with add task, const task equals transcript.slice 9 trim. If task on command detected task, recognition.start return equals recognition.stop on command detected. Export default use voice command. Whenever you say something like add task, buy groceries, the task will automatically be added to the list. Let's add some quick styling to make it look nice. Text align center, font family sans serif, padding 20px, input, padding 10px, width 200px, button, margin 5px, padding 5px 10px. UL, list style none, padding 0. Let's try it out. Simple and super useful Pomodoro timer using React. This is great for productivity and a fun way to practice React fundamentals like state, effects, and intervals. Let's jump right in. First, we'll create a new React app. Open your terminal and run this. Bash npx create React app Pomodoro timer. Once it's done, move into the folder and start the development server. Bash cd Pomodoro timer npm start. That's it. Your app should now be running in the browser. Now open the project in your code editor and head over to the src folder. We'll write all our code in app.js. Delete everything inside app.js and replace it with this full code. Import React, useState, useEffect from React. Function app const time set time equals useState 2560, 25 minutes. Const is running, set is running equals useState false. Const mode set mode useState focus or break. Const cycles set cycles useState 0. useEffect, let timer, if is running. Timer equals set interval equals set time prev. If prev equals 1, handle timer end. Return 0. Return prev is 1, 1000. Return equals clear interval timer. Is running. Const handle timer end equals. Set is running false. If mode equal focus, set mode break, set time 5 to 60. 5 minutes break. Else, set mode focus, set time 2560. Set cycles C+1. Const format time equals. const mins equals math floor time my 60 dot to string dot pad start 0. Const cease equal time sense 60 to string dot pad start 20. Return $mins sex. Const handle reset equals. Set is running false. Set time mode equal focus. 25 tar 60, 5 tar 60. Return div stylic h Pomodoro timer, mode focus, focus time, break time. Div styles timer, format time, styles buttons. Button on click equals set is running, pause, start. Button on click, handle reset. Pomodoro's completed cycles. Const styles equals container, font family, sans serif. Text align center, margin top 50px. Timer, font size 48p, margin 20px. Buttons, display flex, justify content center, gap 10px. Export default app. Save the file and head back to your browser. You'll see your Pomodoro timer already running. Click Start to begin your 25-minute focus session. Once the timer finishes, it will automatically switch to a 5-minute break. After that, it loops back to focus time. It also keeps count of how many Pomodoro cycles you've completed. You can click Pause anytime or hit Reset to start over. Feel free to play around with the durations. Open your terminal and type npx create react app password generator. This sets up a new React project with everything we need. Once that's done, move into the project folder by typing cd password-generator. Now open this project in your code editor. Before writing any code, let me quickly explain what we're building. We're going to create a password generator using React. This app will let users choose the length of the password and whether they want to include uppercase letters, lowercase letters, numbers, and symbols. When they click the Generate button, it will produce a strong random password based on their selected preferences. We'll also add a copy button to easily copy the password to the clipboard. All right, now inside the src folder, create a new file and name it passwordgenerator.jsx. This is where all the logic and UI will go. Now let's write the full component. Import React useState from React. Import facopy from react-icon/fa. Const password generator equals. Const length set length equals useState 12. Const include uppercase set include uppercase equals useState true. Const include lowercase set include lowercase equals useState true. Const include numbers set include numbers equals useState true. Const include symbols set include symbols useState false. Const password set password equals useState. Const generate password equals. Let charset equal if include uppercase charset plus if include lowercase charset equals if include numbers charset equals 012457889. If include symbols charset plus let new password equals. For let I equals 0, I at length, I plus const random index equals math floor math.random charset.length. New password plus charset random index. Set password new password. Const copy to clipboard equals navigator.clipboard.write text password. Alert password copied to clipboard. Return div style max width 400 margin auto padding 20 font family sans serif. Password generator. Password length. Length input type will range min 4 max 32 val length on change e equals set length. E put type checkbox checked equals on change equals set include uppercase include uppercase. Include uppercase. Input type checkbox check include lowercase on change set include lowercase. Include lowercase. Label. Input type will checkbox check to include numbers on change equals set include numbers include numbers include numbers. Label input type checkbox check to include symbols set include symbols include symbols. Button on click generate password. Stylix margin top 10. Generate password. Password and div style margin top 20. Input value password read only style width 80%. Button on click copy to copy of. Export default password generator. Now let's hook this component into our main app. Open app.jsx and replace everything with import React from React. Import password generator from password generator. Function app. Return div password generative. Export default app. To use the copy icon, we need to install one dependency. Go back to your terminal and run npm install react icons. This will give us access to thousands of icons, including the clipboard icon we're using. Now just run npm start. This will launch the app in your browser. You'll see the password generator interface with a slider for length, checkboxes for character types, a generate button, and an input showing the password. You can click the copy button to copy the password instantly. And that's it. You now have a fully functional password generator built using React. We're going to build a simple expense tracker using React. Let's start by creating a new React app. Open your terminal and type npx create React app expense tracker or cd expense tracker npm install uuid. Now open the project in your code editor. Inside the sarc folder, create a new folder called components. Let's go to app.js and clean everything up. Replace it with this. Import React, useState, useEffect from React. Import balance from /component/balance. Import income expense from /components income expense. Import transaction list from /components transaction list. Import add transaction from components add transaction. Import app.css. Function app const transactions set transactions equals useState equals const local data local storage.get item transactions. Return local data json.parse local data. useEffect local storage.set item transactions json stringify transactions. Transactions const add transaction equal transaction set transactions transact transactions. Const delete transaction equals id equals set transactions transactions.filter t.id equals id. Return div class name container expense tracker balance transactions transactions income expense transactions transactions. Transaction list transactions equal transactions on delete equal delete transaction. Add transaction on add equals add transaction. Export default app. Now inside the components folder, let's create a file called balance.js. Add this code. Const balance equals transactions equals const total equals transactions.reduce ac item plus item.amount 0. Return div class name balance your balance total.tfix2 hwindiv. Export default balance. Next, create another file called incomeexpense.js. Const income expense equals transactions equals const income equals transactions.filter t.amount 0. Reduce axi plus t.amount 0. Const expense equals transactions.filter t equal t.amount 0. Reduce axi plus t.amount 0. Return div class name xp container p class name equal money plus income.tofix2 div for expense class name money minus math.abs expense to fixed 2 if. Export default income expense. Now create transactionlist.js. Import transaction from /transaction. Const transaction list equals transactions on delete equals th3 history list. Transactions.map t. Transaction key t.id transaction t on delete on delete. Export default transaction list. Then create transaction.js. Const transaction equals transaction on delete equals const sign transaction.amount dash plus. Return li class name transaction.amount 0 minus plus transaction.text sign $. Math ab transaction.amount click on delete transaction.id class name will delete bex export default transaction. Now create the final component file. Add transaction.js. Import React. useState from React. Import v4 as uuid v4 from uuid. Const add transaction equals on add. Const text set text useState. Const amount equals useState. Const handle submit equals e prevent default. If text amount return. On add id uuid v4 text amount plus amount set text set amount. Return form on submit handle submit h3 add new transaction. Input type will text placeholder description value equals text. On change e set text e.target.value. Input type number placeholder amount negative equal expense value equals amount. On change e set amount e target value. Button type submit add transaction form. Export default add transaction. Let's also style our app. Open app.css and paste this. css.container, max width 400px, margin auto, padding 20px, background white, border radius 10px, box shadow 0010px ccc, font family Arial sans serif, H2, H3, H4, text align center, dot balance, margin 20px 0, text align center, .inc XP container, display flex, justify content space between margin 20px0, background f0fofo, padding 10px, border radius 5px, money.plus, color green, .money.minus, color red, .list, list style none, padding 0, .list li, background f4f4f4, padding 10px, margin 5px0, position relative, border right 5px solid, list border color green, .list li.minus, border color red, .delete b10, position absolute, right 10px, bop 10px, background right, border none, padding 4px 8px, cursor pointer, border radius 4px, form input, form button, width 100%, padding 10px, margin top 10px, font size 16px, form button, background color hasher 007 BFF, color white, border none, cursor pointer, form button hover, background 56b3. Now go back to your terminal and run bash npm start. Your expense tracker is ready. You can add transactions like salary with a positive amount or groceries with a negative amount. It saves everything in your browser using local storage. That's it. You've built a complete expense tracker in React.